This is it, the end of chapter 10, which means you have an exam coming up. And after this video, all assignments, all quizzes are yours to make sure that you have completed and finished. All right. So, excuse me, section 10.6 is just a continuation of section 10.5. We're going to be solving, but what we will have done in this one is we are dealing with now those double angle identities and half angle identities. So the solving properties still stay the same, but you might have like an extra step in the end to deal with when it comes to the double angle or half angles that you might be solving for. Okay, so let's go ahead and let's start talking through these and figuring out what it is that you guys are going to be doing. So, for instance, right here, suppose that we have already solved the trigonometric equation. Okay, so suppose we've already done the inverse trig, and it says that that the answer was supposed to be 2 pi over 3, or say that the answer was supposed to be 8 pi over 3. But you have to do a little bit extra in here because your problem was a double angle. So like say it was sine 2x equal to, I don't know, 2 pi over 3 was 3 square root of 2. Okay. So 3 square roots of 2. Really? Was that? No, that's square root of 3 over 2. Sorry. So say this is what the original problem looked like. You're not coming up with this, but say this is what the original problem looked like. So when I take sine inverse, the sine inverse has canceled out the sine there, leaving you with 2x. And then sine inverse of square root of 3 over 2, when is sine square root of 3 over 2? One of the answers is 2 pi over 3. Okay, so you can see that this part right here, the inverse has already been done. I've gotten my answer, but I have a little bit more because this is not just x left like what we had before. When we did section 10.5, this would have just been the answer, x equals this. But this is not just x anymore. It is now 2x. So now we have 2x equal to 2 pi over 3. So some of these problems in here in 10.6, after you take the inverse trig, you might have to take it a step further. And that's what these two problems are dealing with. You're taking it a step further. It's been solved, but now it wasn't just x that we had left. We had 2x left. So how do I get this x by itself now? All I'm going to do is divide by 2. Okay? So x is equal to, remember, we don't really divide by numbers, we multiply by the reciprocal. So 2 pi over 3 is being multiplied by the reciprocal of 2 is 1/2. So the real answer to this x is 2 pi over 6, which reduces to pi thirds. That's the real answer to that. That's what x really equals. Okay? Over here, how do I get rid of division of 2? Multiply by 2. Remember, this 2 is over 1. Okay? So x is equal to 8 times 2 is 16 pi all over 3. And that does not reduce. So that would be the final answer for x. So again, basically what these two problems are and what you're kind of going to see in your assignment for this first problem, it's like the hard part has already been done. Okay? The hard part has already been done. They've solved. They've done the inverse trig. They've gotten your answer here. Now you just need to take it a step further. And notice you're either going to divide by 2 or you're going to multiply by 2. And that's it. Okay? So let's take a look at another one. Let's take a look at this one. Okay? And let's do some solving. Now, what's also cool and interesting about these is you don't always end up with just, you see how this is x and this is 2x? Well, we can't really solve this the way it is. Even though it's just cosine, we can't really solve this the way it is. So sometimes in these, you might have to use some of those trig identities that we learned about in section 10.3 when we talked about double angle and half angles. So if you look back up here, maybe there's a better way to deal with cosine double angle than just leaving it as that. Okay? So notice that we have cosine over here. Is there a formula that I could change this out with that might be a little bit easier to deal with instead of having this as a double angle? Because as a double angle and this one not a double angle, it doesn't work like that. Okay? So pause the video, take a look at your trig double angles that you got up here. There are 3 different cosine ones, and see if there's a better one to use, and go for it and try and solve this. Pause the video and go. Okay. So if I go back and I look at these, I have cosine x already. So it wouldn't be of great interest to me to add a new trig function in like sine. So don't use either one of these top ones. But if you look right here, 2 cosine squared a minus 1. I can use that. I can change this for 2 cosine squared x minus 1. Notice it's not a double angle anymore, and it's like cosine x. And I have cosine x. So that makes this a whole heck of a lot easier to deal with. And now, hopefully you see that, this is probably like factoring. And you bet, this is just like factoring. Set this thing equal to 0 and solve. Hopefully you did that. If you didn't, pause the video and do that now. Okay, so I'm going to grab everything over here and move it over here because I like my x squared, my squaring part, to be positive. And if I move this over there, that's going to make it negative. I don't like working like that. So I'm just going to move all this stuff over here. So I'm going to subtract. Oops, I don't want this to be red. I'm going to subtract the square root of 3 cosine x, and I'm going to add 1. So add 1 and subtract the square root of 3 cosine x. So what do I got? 0 equals 2 cosine squared x. Those cancel out, minus the square root of 3 cosine x. And hopefully when you got all this all on one side, you're like, oh my gosh, both of these share a cosine. Let's pull out cosine x. And that will leave you with 2 cosine x minus the square root of 3 equal to 0. See? There we go. It was much easier just replacing this with something that we can work with. So sometimes you're not even going to have it where it's a double angle in the end. Sometimes you'll just have it as x, like what we did a moment ago in section 10.5. Okay? So we know how to solve all of these. All we're going to do is set these equal to 0. So I don't know why I wrote an s first. Cosine x equals 0 and 2 cosine x minus the square root of 3 equals 0. So all we're going to do is run inverse cosine. Okay? So this guy over here, we're just going to do cosine inverse, and we want to know when is cosine 0. So we already know that that's going to happen. So if we go over here, cosine column, here's one place, pi over 2. And there's another place right there, 3 pi over 2. So far our answer is pi over 2 and 3 pi over 2. And there we go. And we don't do anything extra because this is just x. If that had been a 2x there, double angle, I would have put 2x and then, manipulated these like what we did here in the beginning. Okay? Over here, we got to do a little bit more work. So we're going to add the square root of 3 to both sides. That gives us 2 cosine x equals the square root of 3. And then we're going to divide by 2. And we get cosine x equals square root of 3 over 2. And so now we just run the inverse cosine like we did last time. Cosine -1, cosine inverse. So x equals, we go to our table. When is cosine the square root of 3 over 2? Stop it. All right. Cosine square root of 3 over 2 is pi over 6. So pi over 6 is one of our answers. And square root of 3 over 2, 11 pi over 6. So pi over 6 and 11 pi over 6. Pi over 6, 11 pi over 6. And there's your answers. Okay? So try not to overthink it. If it seems like you're getting stuck doing the problem, I could see you getting stuck on this one because cosine x and cosine 2x are two different things. Try changing the double angle, or if it's a half angle, changing it to something that you can work with. Okay? Don't just stay on those problems. Change it to something that you can work with. There's nothing wrong with that. All right? So keep that in mind. Keep that in mind. All right. Go ahead, pause the video, give this one a shot. You got this. Okay. So, we want to get cosine double angle by itself. So this one, there's no point in changing this one. I mean, I guess if you really wanted to change it, you could, but I wouldn't. I would just, this is great. Just get the cosine double angle by itself. Okay? So how do we do that? Well, all we're going to do is add 3. So when you have one trig function, just leave it the way it is and solve for it. That gives you 2 square roots of 3 cosine double angle equal to 3. And then divide by 2 square roots of 3. Divide by 2 square roots of 3. So cosine double angle is equal to, now up here we don't like that, so we got to rationalize. So multiply the top and the bottom by the square root of 3, because that's the radical you want to get rid of. And in the end, you'll end up with 3 square roots of 3 over 6. So what you get is square root of 3 over 2. Okay? So we want cosine. We got to get rid of that. We want the 2x by itself. So how do I get rid of cosine? That should have been blue. Jerks. Do your cosine inverse. Cosine -1. Cosine -1. So now you have 2x equal to, well, when is cosine? Square root of 3 over 2. And again, they want this in radians. So cosine is the square root of 3 over 2 at pi over 6. And I think it's actually the same answer that we just had a second ago. Pi over 6 and, Yep, 11 pi over 6. So pi over 6 and 11 pi over 6. So we're going to adjust these answers now. Okay? And we're going to say 2x, because we're not done, is equal to pi over 6. And 2x equals 11 pi over 6. So how do I get x by itself? Divide by 2, divide by 2. X equals pi over 12. Divide by 2, divide by 2. X equals 11 pi over 12. And those are your answers. Okay? Yeah, I don't, if I can work with it as the double angle, it's better. If you actually changed this, I don't think you would get any answers that would have actually fallen on this because we don't have any pi over 12s and things like that on this. So if you actually change this to sines or cosines, I don't think you would have found the correct answers in the end. Yeah. But give it a shot. Let me know. I always like to be proven wrong. But I think you would have had a little bit more work to do on this had you changed this, into 1 minus 2 sine squared or 2 cosine squared minus 1. I think you would have had some work cut out for you. Okay? And I don't think you would have ended up at the answers that we liked right here. Okay? I think you would have had to jump through more hoops. So just be careful. If you got one trig function, then just solve for that trig function. Keep it the way it is and go for it. All right. So pause the video, give this one a shot, and go. Okay. So this one, all the solving is ready. I mean, really all you had to do was take the inverse cosine of both sides. Cosine -1. Cosine -1. But now you have theta over 2 equal to, so we want to know when is cosine negative square root of 3 over 2. So we go up into our picture. Negative square root of 3 over, there's one of them. So 7 pi over 6. And the other one, negative square root of 3 over 2, 5 pi over 6. So 5 pi over 6, 7 pi over 6. And 7 pi over 6. But just like what we did in the last one, it's like two separate problems now because we got to go an extra step. And theta over 2 is equal to 7 pi over 6. So how do I get rid of division? Multiply by 2. Multiply by 2. Multiply by 2. This will give you theta equal to 10 pi over 6, which will reduce to 5 pi over 3. There's one answer. And then over here, multiply by 2, multiply by 2. That will give us theta equal to 14 pi over 6, which equals 7 pi over 3. And there's your answers. Okay. So moving on. I think this is the last problem. think. Yeah. Last problem. So on this one, we want to know when is sine half angle equal to cosine half angle. So this one's a little different. It's a little weird. So when you approach this one, there are lots of ways that you can attack this. Okay. I'm going to show you the algebra way, and then we will talk about the other ways that you can use to attack this kind of problem. Okay. So in algebra, remember that we have this nice little problem, and we can't solve this the way it is right now. Okay. This is too difficult, and it's a little bit harder to change around. But remember, we do know that sine squared plus cosine squared is equal to 1. And we'll just call this x. Okay? So sine squared x plus cosine squared x is equal to 1. Well, we can solve for one of these. Okay? Let's get cosine by itself. So then you know that cosine squared x is equal to 1 minus sine squared x. Okay? So think about it like this now. Know that these two pieces are also going to be the same if both of these sides were squared. Okay? Know that these two pieces are going to be the same if both of those sides are squared. So if you go and look at this, yeah. So if you go and look at this, we can now do a little bit of exchanging. Okay? We can do a little bit of exchanging. So please know that this is also the same thing. Sine squared, half angle, should be the same as cosine squared, half angle. Okay? These are both the same. It's not going to change the answer. So with this being known, and with this being known, we can do some exchanging, and we can solve. We can trade the cosines out. And what we get is sine squared x over 2 equal to cosine squared, just switch these two pieces out with each other. This is going to go in there. And that will give you 1 minus sine squared half angle. So if we get everything all on one side and do some factoring now this makes this a whole heck of a lot easier to work with. But this was the key right here. And knowing that squaring both sides will not change your answer. It's going to be the same. Okay? So we're going to add sine squared back over here. And that's going to give us 2 sine squared x over 2 equal to 1. And then you're going to keep solving. Okay? So we're going to divide this by 2 to get rid of multiplication. And now you have sine squared x over 2 equal to 1/2. How do you get rid of something squared? Square root it. Now remember, when you take a square root of both sides, that makes this side become plus or minus. And then remember, we talked about we don't have a fraction under a radical. We split it up. And then you're going to have to rationalize. So this whole side becomes the square root of 2 over 2. Okay? All right. Now, we're almost done. How do I get rid of sine? We're going to take the inverse of both sides. So, sine -1 and sine -1. We want to know, when is sine positive square roots of 2 over 2 and negative square roots of 2 over 2? Okay? So, x over 2 equals, when is sine positive square root of 2 over 2? Okay. Well, sine is positive square root of 2 over 2 at 45 pi over 4 and 3 pi over 4. So pi over 4 and 3 pi over 4. When is sine negative square root of 2 over 2? Well, that happens at 5 pi over 4 and 7 pi over 4. Okay? So then, now, let's take a look at some information. So we want to figure out all these pieces of information, but it's a half angle. So what do I got to do with all these answers? I got to multiply them by 2. So x is really equal to the following pieces of information. Pi over 4, when multiplied by 2, becomes pi halves. 3 pi over 4, when multiplied by 2, becomes 3 pi over 2. Pi over 4, or 5 pi over 4, when multiplied by 2, becomes 5 pi halves. And 7 pi over 4, when multiplied by 2, becomes, about wrote the wrong answer. 7 pi halves. Now, here's the thing. Some of these answers you have to throw out. Some of these answers you have to throw out. How do I know that? Well, first off, our interval was over 0 to 2 pi. Okay? So our interval for x is from 0 to 2 pi. However, our piece is working with x as a half angle. Okay? Our piece is working with x as a half angle. So, with that being known, the original interval is like this, but Rx is all about a half angle from the very beginning. So what does that do to my interval up here? Well, that means this interval also needs to get cut in half. So 0 is 0, and 2 pi divided by 2 becomes pi. So some of these answers have to go. Actually, sorry, hold up 1 second. Yeah, we could have talked about it. Yeah. Let me go ahead and put that back on there. And I'll tell you, what we're dealing with here. All right. So you could have canceled them one of two ways. So our final answer for x has to be between 0 and 2 pi, right? Well, some of these answers are not between 0 and 2 pi. For instance, 5 pi over 2 and 7 pi over 2. Those problems are above 2 pi. Because if you look at it in the calculator, 5 pi divided by 2 is 7.85. 2 pi is 6.28. See how that answer is out. It is above 2 pi. So that's why we have to throw that out. And the same thing with 7 pi over 2. It is above that 2 pi. So these two answers get thrown out. And these are the only viable answers that we can work with now. Okay, but we're not done, just so you know. The other thing is, if we were back here, remember how I related this, how in the beginning we were working with x over 2 pi? Or sorry, x over pi. So right here, we could have actually figured out which answers to throw out, because I only want answers that are between 0 and pi. Well, this answer and this answer are above pi. Okay? The only ones that are below pi are 3 pi over 4 and pi over 4. So I could have eliminated two of these extra answers in here based off of the interval for x over 2, the half angle, or in the end, I can look at my interval and eliminate based off of x. So this is where it's going to be important to watch those intervals. Okay? Now, the other thing that happened in here, because we did squaring in the beginning, because of this guy, and we squared it, because of this, we do have to check our answers in the end. So we do need to check and make sure that if we plug in sine of pi over 2 divided by 2, is that going to be the same thing as cosine pi over 2 divided by 2? And it's because of the squaring we have to check this. And then the same thing is sine 3 pi over 2 divided by 2 going to be the same thing as cosine 3 pi over 2 divided by 2. Okay? Well, the question is, basically all they're asking is sine pi fourths, because pi halves divided by 2 is pi fourths, the same as cosine pi fourths. And then over here, they're asking, is sine 3 pi fourths the same as cosine 3 pi fourths? So if we go to our handy dandy Bible, so pi fourths, yep, they're both the same. Square root of 2, square root of 2, square root of 2 over 2, square root of 2 over 2. If you go down to 3 pi fourths, notice they are not the same. This is why we do that check. The cosine is actually a negative square root of 2 over 2. So this checks out because it's the square root of 2 over 2 on both sides. So that checks. So pi fourths is a valid answer. Or in other words, x equal to pi halves. That's one of our true answers. But over here, this did not check out. You ended up with the square root of 2 over 2 equal to negative square root of 2 over 2. And that was wrong. Okay? And there we go. All right, so now just want to talk to you about some other things that you will see in here. So some of the questions are going to ask you about finding all exact solutions, just like what we did in 10.5. So say I wanted all exact solutions for this. Okay? So our answer would be pi halves plus, okay, pi halves plus, now we got to think about what's going on here. Okay? I need all exact answers. When we began this, our x is all about x over 2. Okay? What's the period of sine and cosine? It's 2 pi. But remember, that's a normal period. Okay? We are dealing with a half angle period. So what does a half angle do to a normal 2 pi period? It turns it into 4n pi. So if I want all the exact angles for this, my period has been stretched to 4 pi. Because you got to multiply both sides by 2. Okay? So if I want all the exact solutions for this, it's really going to be pi over 2 plus 4n pi. Over here, if I want all the exact solutions for this, okay, what would that answer look like? Give it a shot. Go. Okay, remember the period for cosine is 2 pi. All right? So if I take, sorry, just double checking something. So these are my answers, right? Cosine's period is 2 pi. But that's if you're working with a regular x. And here we're working with a half angle. So what does the real period for this look like? It's going to be 4 pi. So that means these answers will be 5 pi over 3 plus 4n pi. This answer right here would be 7 pi over 3 plus 4n pi. Okay? So there we go. There's your answers. It's a little weird. Your intervals adjust when you're working with half angles and double angles. Because remember, you're messing with the period. Because that's like a B. All right. Go ahead, pause the video, and give me all the solutions for these two. And go. All right. So this one was just a little bit different, but nothing crazy. Okay. So remember cosine again, period is 2 pi. But that's when you're working with a regular x. We have 2x. So what does that do with my period now? Cuts it in half because you'll have to divide by 2. So my answers, if I want all the exact solutions, will be pi over 12 plus n pi. And this guy will be 11 pi over 12 plus n pi. And there you go. And that, my friends, is 10.6. That wraps up chapter 10. Everything is yours now in chapter 10 to finish up and do. All assignments, all quizzes. Good luck, and I'll catch you when you're ready for your exam. Bye.